Coconut oil-based short oil Alkyd resin, synthesis, properties, modifications, and applications. Coconut oil-based short oil Alkyd resins constitute an important class of bio-derived polyester binders widely utilized in coatings, paints, and emerging surfactant systems. These materials are typically formulated as waterborne, white, viscous liquids and are valued for their rapid drying behavior, high gloss, and excellent resistance to yellowing. Derived from renewable coconut fatty acids, they provide a sustainable alternative to petroleum-based materials while maintaining desirable mechanical and optical properties. This report presents a comprehensive overview of their chemistry, synthesis, functional modifications, and industrial applications, with emphasis on their role in coatings and detergent formulations. Alkyd resins are synthetic polyesters produced through condensation reactions between polyhydric alcohols, polybasic acids or their anhydrides, and fatty acids. They function primarily as film-forming binders in paints, varnishes, printing inks, and water-thinable coatings. Their widespread use is attributed to their ability to form continuous films with excellent adhesion to substrates, along with good durability, high gloss, and relatively low production cost. The drying characteristics and mechanical performance of Alkyd resins can be tailored by adjusting the composition and oil length. Short oil Alkyd resins, which contain a relatively low proportion of fatty acids, exhibit faster drying rates, higher hardness, and improved resistance to chemicals compared to medium and long oil variants. These properties make them particularly suitable for industrial coatings and baking enamels. The incorporation of coconut-derived fatty acids into Alkyd resins enhances their performance further by introducing saturated hydrocarbon chains, which improve color stability and reduce oxidative degradation. As a result, coconut oil-based Alkyd resins are increasingly favored in applications requiring non-yellowing finishes and long-term aesthetic stability. Coconut fatty acids as renewable raw materials. Coconut fatty acid, obtained from the hydrolysis of coconut oil, is a renewable and plant-based feedstock consisting predominantly of medium-chain saturated fatty acids. Lauric acid typically constitutes approximately 45 to 58% of the mixture, while myristic acid accounts for about 16 to 23%. The high degree of saturation in these fatty acids imparts significant oxidative stability, which is directly reflected in the improved color retention and resistance to yellowing observed in coconut oil-based Alkyd resins. Beyond polymer synthesis, coconut fatty acids are widely used in personal care products, soaps, lubricants, and plastics due to their favorable foaming, cleansing, and conditioning properties. Their renewable origin and biodegradability make them particularly attractive for sustainable materials development, aligning with the principles of green chemistry. Characteristics and applications of coconut oil-based short oil Alkyd resins. Coconut oil-based short oil Alkyd resins are commonly supplied as viscous, waterborne liquids that can function either as primary binders or as additives in coating formulations. These materials are compatible with a wide range of coating systems, including polyester urethane gloss coatings, polyester surface coatings, acid-cured paints, and nitrocellulose-based lacquers. The resulting coatings are characterized by rapid drying, high gloss, excellent color retention, and strong resistance to yellowing. The performance advantages of these resins arise from their molecular structure, in which a polyester backbone is modified with saturated fatty acid chains. This structure provides a balance between rigidity and flexibility, enabling the formation of hard, durable films with good adhesion and surface smoothness. Consequently, these resins are widely used in applications such as baking enamels, cabinet finishes, furniture coatings, and industrial lacquers. In addition to their role as binders, they may also act as plasticizers or resin modifiers, enhancing the flexibility and processability of coating systems. Synthesis of coconut oil-based Alkyd resins. The synthesis of coconut oil-based short oil Alkyd resins involves esterification and polycondensation reactions between polyols, polybasic acids, and coconut fatty acids. Common polyols include glycerol, trimethylolethane, and neopentyl glycol, while typical acid components include phthalic anhydride and adipic acid. The reaction may be carried out using either a single-stage or a two-stage process, depending on the desired control over molecular architecture. In the two-stage method, the initial step involves alcoholysis, in which triglycerides from coconut oil react with polyols to form partial esters. This is followed by a polycondensation step, where the partial esters react with polycarboxylic acids to form a cross-linked polyester network. Alternatively, all reactants may be combined in a single-stage process and heated to promote direct esterification. A representative preparation involves heating a mixture of phthalic anhydride, adipic acid, trimethylolethane, and neopentyl glycol to approximately 160 degrees Celsius under agitation, followed by gradual heating to around 230 degrees Celsius. Coconut fatty acids are then introduced and allowed to react at this temperature for approximately 2 hours. To facilitate the removal of water generated during esterification, a small amount of xylene is added, enabling azeotropic distillation. The reaction is continued until the acid value decreases to approximately 5 mg potassium hydroxide per gram of resin, indicating near complete esterification. The final product is diluted with xylene to obtain a solution of about 60% solids, with a viscosity of approximately 10.7 Stokes at 25 degrees Celsius. The resulting resin typically contains around 15% fatty acid content and exhibits an average functionality of approximately 2.6. Polymeric surfactants derived from Alkyd resins. Recent developments have demonstrated that coconut oil-based short-oil Alkyd resins can be adapted for use as polymeric surfactants in detergent formulations. These materials are synthesized using a combination of coconut oil, rosin, glycerol, and maleic anhydride, resulting in what is often referred to as a rosinated short-oil Alkyd resin. The high rosin content, typically in the range of 50 to 60%, contributes to the hydrophobic character of the polymer, while the incorporation of maleic anhydride introduces polar functionality that enhances water compatibility. Such polymeric surfactants exhibit effective foaming and cleaning properties and can serve as partial or complete replacements for conventional petroleum-based surfactants such as acid slurry and alpha-olefin sulfonate. Their performance can be tailored by controlling the molar ratios of reactants, catalyst concentration, and reaction conditions, thereby achieving the desired hydrophilic-lipophilic balance, viscosity, and solubility. Experimental studies have shown that detergent powders formulated with these Alkyd-based surfactants, either fully or partially replacing conventional surfactants, exhibit satisfactory cleaning performance while maintaining appropriate moisture content. The use of renewable raw materials such as coconut oil and rosin also contributes to cost stability and environmental sustainability. Modification of Alkyd resins. The performance of coconut oil-based Alkyd resins can be further enhanced through chemical modification, particularly by incorporating vinyl-type monomers. Acrylic-modified Alkyd resins are of particular interest, as they combine the favorable film-forming properties of alkyds with the durability and weather resistance of acrylic polymers. Such modifications are typically achieved by reacting acrylic monomers, such as methyl metaacrylate or ethyl acrylate, with an alkyd intermediate. The reactivity of Alkyd resins toward vinyl monomers depends significantly on the nature of the oil component. Drying oils with high levels of conjugated unsaturation, such as dehydrated castor oil, react more readily but are prone to discoloration and loss of gloss over time. In contrast, saturated oils such as coconut oil exhibit lower reactivity but provide superior color stability and resistance to yellowing, making them more suitable for high-performance coatings. However, the formation of homogeneous alkyd acrylate copolymers can be challenging. In some cases, incomplete compatibility between the alkyd and acrylic components leads to phase separation or heterogeneity. The use of higher alkyl acrylates, such as butyl acrylate, can help mitigate this issue by providing internal plasticization and improving compatibility. Coating formulations. Coconut oil-based Alkyd resins, particularly when modified with acrylic components, are widely used in advanced coating formulations. These systems typically consist of a dissolved alkyd acrylate copolymer, and amine formaldehyde resin serving as a cross-linking agent, a suitable organic solvent system, and dispersed pigments. The solvent system generally comprises mixtures of esters, ketones, and alcohols, sometimes with minor amounts of hydrocarbon solvents, to ensure adequate solubility and application properties. The inclusion of amine formaldehyde resins enhances cross-link density during curing, resulting in improved hardness, chemical resistance, and durability. Such formulations are commonly employed in automotive finishes, metal coatings, and decorative paints, where long-term performance and aesthetic quality are critical. Environmental and sustainability considerations. The use of coconut oil and other plant-derived materials in Alkyd resin synthesis reflects a broader shift towards sustainable and environmentally friendly chemical processes. These bio-based resins reduce dependence on fossil resources and offer potential advantages in terms of biodegradability and reduced environmental impact. Furthermore, their application as polymeric surfactants in detergents provides an opportunity to replace conventional petroleum-derived chemicals with renewable alternatives, thereby supporting the principles of green chemistry. In conclusion, coconut oil-based short oil alkyd resins represent a versatile and sustainable class of polymeric materials with wide-ranging applications in coatings and detergents. The unique combination of rapid drying, high gloss, and resistance to yellowing is primarily attributed to the incorporation of saturated coconut fatty acids into the polyester backbone. Advances in synthesis and modification, particularly through the incorporation of rosin and acrylic monomers, have further expanded their functionality and performance. As the demand for environmentally friendly materials continues to grow, these bio-based alkyd resins are poised to play an increasingly important role in modern industrial formulations.